Okay, girls, so this is example 1 on the accompanying document. So this is about intersections and collisions. And the first one says at a certain instant in time, x, this body x is 40 metres due north of y. So I'm going to put y at the origin and I'm going to put x up here, 40 metres due north of it. And it tells me that x is moving with a velocity of 10 root 2 in a southeast direction. Okay, so here's x, 10 root 2 in a southeast direction. So velocity of 10 root 2. If it's travelling southeast, it means, of course, that this angle there is 45 degrees. Y is moving with a velocity 10 metres per second in an easterly direction. That's going along at 10. You've got to show they will collide and deduce the time of collision. Okay, so for my condition for a collision, if there's going to be a collision, then the slope of the relative velocity will be equal to the slope of the relative displacement. So my job is to find the position of x and y and the velocity of x and y. So that if I find the positions of them, that will tell me their relative displacement to each other. Okay, so these are, first of all, their displacement. Where are they? As far as that x, y axis or ij axis is concerned. So I'm going to call the displacements r. Where is the displacement of x? Where is x at the moment? It's 40 metres up the j-axis. So I'm going to say it's 0i plus 40j. And where is y? Y is at the origin, so that's 0i plus 0j. Now, their relative displacements, that means I'm looking for the r of xy, which of course is rx minus ry. So rx will be 0i plus 40j, and of course I'm going to take from that 0i plus 0j, which will just be 0. And when I do that, I get 0i plus 40j. So that's their relative displacement expressed in terms of I and j. Now, let's get their relative velocity now. So I want the velocity of x and the velocity of y. And then I can get vxy, which of course is vx minus vy. So the v of x, what's the velocity of x? I'm going to draw a right angle triangle around x here. This will be the j component, this will be the I component, and now I'll write its velocity in terms of I and j. So the Vx, the hypotenuse up here is 10 root 2, so it's going to be, and it's going in a positive I direction, so it's 10 root 2, the sine of 45 in the I direction, sine because it's opposite that angle, minus 10 root 2, the cos of 45 in the j direction, and minus because it's coming down the j-axis. So when I work that out, sine of 45 is 1 over root 2, the cos of 45 is 1 over root 2. This becomes 10i minus 10j. And what's the velocity of x? X is just travelling at 10 metres per second in an I direction, so that's going to be 10i plus 0j. So the vxy would be 10i minus 10j minus 10i plus 0j. And when I subtract those, I'll get 0i minus 10j. Okay, so now I have the relative velocity and the relative displacement. Okay, let's see, is this the case then? What's the slope of the relative velocity here? So the slope of the relative velocity, if I was to draw the relative velocity, look where it is. It's 0i minus 10j, so it's going along the y-axis in a downward direction. Where's this? This is 0i plus 40j. It's going up the y-axis in a positive direction, but it's travelling along the y-axis. So they are the same. Now let's go to slopes. The slope of the y-axis, a couple of things here. Remember, the slope is the tan of the angle that a line makes with the y-axis. So if this is the j-axis where that vector is, that angle is going to be 90 degrees. So the slope of that line is the tan of 90. And of course the tan of 90 is undefined. And it's undefined because if you try to find that slope, you'd put the j's over the i's, which in this case would be 40 over 0, which of course is undefined, we say. It's infinity. And infinity means it's undefined. Now this is the same. It goes off to infinity. What's the slope of this line here? Is making an angle of 90 degrees with the y-axis. So of course the slope is the tan of 90, which in this particular case is minus 10 over I. And when I'm finding slope, I always keep the sign. Again, you can't divide that, and that's infinity. So again, it's undefined. So it's just a handy little one to do because we haven't come across the slope of the y-axis yet. This is our first time, I think, coming across the slope of the y-axis. Okay, so we can see that those two slopes are equal. So the slope of the relative velocity is undefined and the slope of the relative displacement is undefined. Therefore, there will be a collision. And the second thing I had to do was find the time to the collision. Find when it happens. Now, from your sheet, you'll know that the time to a collision is equal to relative displacement over relative velocity. Where am I getting that from? Speed is equal to distance over time. So time is distance over speed. And distance in this case will be relative displacement divided by, of course, relative speed. So it's all... And I'm going to get modulus just to make it easier. Okay, so relative displacement would be distance and relative velocity would be speed. I should really say relative velocity here. Okay, so what's the time? The time is equal to, I know what the relative displacement is. It's 0I plus 40j. I'm going to get the modulus of that and divide it by the relative velocity, which of course is 0I minus 10j. And get the modulus of that. So to get the modulus of this, remember it's the square root of the I coefficient squared plus the j coefficient squared, which is 40 squared. And this one would be the coefficient of the minus 10 to be squared. And of course when you do that you just get 40 over 10. So in 4 seconds, that's when collision will happen. Now the next part of the question says, where does this happen? Where does the collision happen? So the position of the collision now is the next one. So position of collision. So back to the beginning again. Here's x, y was at the origin, and they're going to continue on for 4 seconds going in the direction that they're going, and they'll collide. We've proved that there will be a collision. We just want to see where it will happen. So it's going to happen, obviously we can see that if this doesn't move from the y-axis, it's going to happen somewhere along that y-axis. Okay, so again, we're going to use the idea that speed is equal to distance over time. So the displacement in this case, that will be speed multiplied by time will give me my displacement. And I'm saying speed, but I suppose I'll say velocity multiplied by time will tell me the displacement, how far it's gone. So let's look at x. We only need to do one of these, but I'm going to do both of them just to prove it to you. So let's take position x. X, where is it? Its position it's at 0I plus 40j. Okay, and it's going to travel along for 4 more seconds at the velocity with which it's going at, and then we'll see where it is. So that's where it is now. Where will it be in 4 seconds time? Right, so if it's travelling with a velocity of 10I minus 10j for 4 seconds, it will have gone 40I minus 40j. That will be its new displacement. So that was its original displacement, 0I plus 40j. Right, I'm going to add on this how far it's gone, or with the displacement that it's undergone. And when I add this, I'll just get 40I That'll be 0j. So it is along the I-axis, as we know, as we've sort of deduced already. And we could do the same for y. Y should give us exactly the same answer, because if they're going to collide, they've got to be in the same position. So y is at 0I plus 0j. Its velocity, we've already said, was 10I plus 0j. Okay, it's going to go along for 4 seconds. Where's it going to be? It's going to be at 40I plus 0j. It was at 0I plus 0j originally. Now we've added this displacement on. So again, it's now at 40I plus 0j. These two have to be the same, because that's where the collision happens. So they have to be in the same position. You don't have to do both of them, you just do one of them. But I'm just showing you both of them just to prove it to you. Okay.